In this video, we're going to talk about a couple more types of factoring. Last video covered 2 different types, and then we're going to talk about some more here today in this video. The first thing is, if you look at this section, it is on perfect cubes. That you probably haven't spent as much time with perfect cubes as you have with perfect squares, but there's something you need to know. Cubes you need to know about. You know that the third power means times itself 3 times. So 2 to the third means 2 times 2 times 2. So what I want you to do right now is you don't have to write them all out, just calculate either in your head or with a calculator, what is 2 to the third power, and I'll tell you it's 8. What is 3 to the third, 4 to the third, etc. So pause it here and fill in this section. Okay, so here's the deal with perfect cubes is you really need to memorize them. Just like perfect squares, you just kind of know what they are in your head so that when you have to do something with a perfect square, you know what the perfect square is. Well, same thing with cubes. You need to memorize them so that when we have things pop up, you just go faster. I'm not going to have a test or a quiz on what are all the perfect cubes, but it'll help you go faster. It'll help you go faster on tests, on quizzes, on things like ACT. So just memorize those and be familiar with those. The first method of factoring that we're going to talk about in this video is dealing with perfect cubes. So we have 2 different possibilities. The sum of 2 cubes, like a cube plus a cube, or the difference of 2 cubes, like a cube minus a cube. And then we have these patterns. Now, when we did perfect squares, I didn't really make you memorize the pattern because you could kind of just do it without memorizing it. This, however, I'm not sure how you would do it if you didn't memorize it. It's not logical. It doesn't come to you very obviously. So you're going to have to memorize these. And so these patterns here, you have to memorize what's in these boxes here. And we're going to talk about it. One thing that I encourage you to use to memorize them is this little mnemonic called SOS. SOS stands for same opposite sum. And what I mean by that is if you look at the pattern, if this is a plus sign, then our first sign is the same, plus. The next one is the opposite, minus, and the last one is the sum, plus. Let's look at the next one. This is a minus, or no SOS. S, same, O, opposite, S, sum. So same, opposite, sum helps us memorize what signs to use, because other than that, look, they're exactly the same. A, B, A squared, AB, and B squared. So just memorize the letters, the A's and the B's, and then SOS will tell you what signs to fill in. Okay, what am I even talking about? Let's look at the first example. This first example is not in standard form, and I don't know why it's not in standard form. It's not. But what we're going to do is we're going to take this first term to be our A. Well, it's our a to the third, actually, and then the second term is our b to the third. So in other words, what I mean is, for finding our a, we're going to take the square root of 8, which is 2, and for b, sorry, that's not a square root, that's a cube root. And for b, we're going to find the cube root of x cubed, which is x. And so when we start this out, we're going to have 2 terms in our first set of parentheses, and we're going to have 3 terms in our second set of parentheses. If we think about SOS, it's going to be same, opposite, sum. Now, we just need to fill in the blanks. To fill in the blanks, look at the pattern. The first one is just a plus b or a minus b. That is 2 plus x. The next set of parentheses has an a squared, well, that's 2 squared, minus ab, which is 2x, plus b squared, which is x squared. Now, I do need to simplify this, but this is just the pattern that I'm copying from this box right here. I should simplify this. The only thing I really need to simplify is that 2 squared is 4. And so this is my final answer, 2 plus x times 4 plus 2x plus x squared. Now, if you don't trust me, or maybe you don't trust yourself, like if you're on a quiz or a test and you want to check your answer, well, the way you can check it is just multiply it back out again. And so if I multiply this back out again, I'm just going to distribute this first one, distribute the second one, and see what I come up with. Okay, as I multiplied it out, I kind of ran out of space, but it's also kind of helpful how I set it up, kind of coincidentally. And so when I multiplied it out, since I ran out of space, I've lined up the like terms, which if you had space, you might not have done that. It doesn't matter. But I can notice here that my like terms, look at that. Those are going to cancel, and those are going to cancel. And so if I simplify this, what I really have is 8 plus x to the third. And I was checking, and that is what my original problem was, so I must have done it right. You do not have to do a check on every problem, but I just am doing it there so you can see how it works and understand that it does work, and also understand that if you're on a test or a quiz and you have extra time and you want to check your work, that's how you would do it. Let's look at this next example. Okay, the first thing is I want to take the cube root of the first term and the cube root of the second term. But as I do that, I'm looking at 4 and I'm thinking that is not a perfect cube. Well, look, I have a GCF. So I'm going to take out my GCF. And in this case, it looks like my GCF is going to be 4x. And so if I factor out my GCF, I get x to the third plus 27. Let's use this, x to the third plus 27, when I'm figuring out my a and b. So a is the cube root of x to the third, which is just x. B is the cube root of 27, which is 3. And so now I can factor that down using the pattern. I'm going to keep my 4x there off to the side. And then remember, the first one has 2 terms. The second one has 3 terms. Again, it's a plus, so I'm going to do same, opposite, sum, and now I'll fill in the blanks. Why don't you pause it here and see if you can fill in those blanks. All right, when you factor it out, x plus 3, that's your a plus b, and then x squared minus 3x plus 9, that's your x squared, and your b squared, and your ab in the middle. Excuse me, a squared, b squared, and ab in the middle. Same, opposite, sum. Also remember, 4x is part of your answer. Don't drop off that 4x. You need that in there. Okay, next problem is a subtraction problem, but that doesn't really change things a whole lot. I don't think it's going to trip you up. We need to do an example of it, but I don't think it's going to trip you up. Also, out here in the margin, I'm showing my work. You will get to a point where you don't need to show this. You can, if you want to stick with this method of showing work, do that. But a lot of you won't need to show work, and that's okay. Now, with the minus signs, you don't have to include the negative here. In fact, don't include the negative here. That's going to mess you up. Just follow the SOS rules with the signs and just use the absolute values of these. Okay, so my first parentheses is going to be 5d. This time it's minus 2. So same, opposite, sum. Okay, so it's going to be minus 2. Then I square that. Well, 5d, quantity squared, is 5d times 5d. That's 25d squared. Middle term is you multiply those two together. So it's 2 times 5d. That's 10d. And then my last term is 2 squared. That's 4. Look at number 4. Once again, remember, we're supposed to take the cube root to find these. I'm looking at 2 and 16. And x squared and x to the fifth, those do not seem like perfect cubes. That means we needed to factor in a GCF. In fact, that might be worth writing in the margin. Let's go ahead and write that in the margin. Okay, so if they're not perfect cubes, look for a GCF. Our GCF here looks like it's going to be 2x squared. And that leaves us with x to the third minus 8. So that's going to be what we're using to find our a and b. So we have our 2x squared. We have x minus 2, same opposite sum is going to be a minus there. And then we just fill in these 3. And so once again, don't worry about the minus sign here as far as your a and b. Just let the SOS work out the rules with the signs. All right. So that is your final answer. 2x squared, x minus 2 times x squared plus 2x plus 4. Now, some of you might also think that these look like a perfect square trinomials. They kind of do, but they are not perfect square trinomials. There's no way to factor that down. A perfect square trinomial that would have a 4x here. And if I'm looking up here, that would have a 20d there. So it's not a perfect square trinomial. I know it looks like one. It's close, but that middle term is only half of what it needs to be in order for it to be a perfect square trinomial. So we're going to stop there. We're done. Okay, let's turn the page. Okay, one more kind of factoring. This kind of factoring I really think it's cool. It is mind-opening. You realize that you can do things you didn't know you could do, but it's basically using substitution to substitute stuff in and work out kind of whatever you want to work out, which is really a pretty neat concept. So first of all, I call this the U method, and most textbooks use the letter U. I don't know who chose U and why we're using it, but that's what we're going to use. You look up here, the polynomial AU squared plus BU plus C is in quadratic form when U is any function of X. Identify U and factor each expression simplifying the factors if possible. Why would you ever want to use this and when? Well, when is when one thing is if you have something to the fourth power. Look, we have 2x to the fourth power. We haven't really talked about how to factor fourth powers because we have a trinomial, but it's a fourth power. In fact, we might write trinomial here. But if that happens, that is basically a candidate for using the U. And honestly, sometimes they're really funky and there's not really anything else you could use, so try U and see if that works. Okay, what in the heck is U? Here it is. U comes from the variable in the middle term. Let me show you what I mean. On this first example, here's my middle term, and so U is x squared. Well, if U is x squared, then U squared must be how much? Well, U squared must be x to the fourth. And so let's rewrite this using U's instead of X's. Seems a little strange, but what it did is it gave us a quadratic and a trinomial, and we know how to factor trinomial quadratics. We spent a lot of time with this last chapter, right? So we know how to do this. You could do this with the box method. You could do it with splitting the middle term. I am a fan of guess and check, especially when we have prime numbers. So since 2 is prime, I'm going to try a guess and check. All right, I'm going to put a 2 here and a U here, a 2U here and a U here, because 2 is a prime number, so I can guess and check with those numbers. Now with my 9, I have to decide, is it 1 and 9, or is it 3 and 3? Since my middle term is just a 3, I'm going to guess it's 3 and 3. Let me try 3 and 3 and see what happens. And one of them needs to be negative. So I'm looking at this and I'm kind of guessing it and checking it in my mind, and I'm thinking the 6 needs to be positive, the 3 needs to be negative. So this is 2U squared plus 6U minus 3U. That's plus 3U, which I wanted, minus 9. The last step here is not to forget to plug in the x's that we used to have. Okay, so we have to plug our x's back in. So remember, U was x squared. So instead of 2U, we need to go back to calling that 2x squared. And U, again, was x squared, so we'll call that x squared. And now I am done. If these could be factored any further, I would need to factor them. But this can't be factored anymore, so I'm done. That is the U method. I know it's kind of strange. I don't know. I feel like it's revolutionary. I feel like, wow, I can do that. Yes, you can do that. So let's take a look at a couple more examples, actually. This next one is a little bit different because our U is kind of bizarre. To find the U, we go to the middle term and we look at the variable in the middle term. So in this case, U is going to be a plus 2. And so if U is a plus 2, then U squared must be a plus 2 quantity squared. Now, how did I know even to use the U? Well, it didn't really fit my first criteria, being an n to the fourth. But when you can't do anything else, it sure fit that. I would not know how to do this otherwise. I'm trying to factor it, remember? So factoring, how am I going to factor that? Let's try U. All right, so now what we have, since a plus 2 is U, I have U squared minus 12U plus 32. I need to think of if I can factor that. Well, once again, I'm going to use guess and check factoring because it is a leading coefficient of 1. So all I really need to do is find the factors of 32, which add up to negative 12. Well, I know 4 times 8 is 32, and 4 plus 8 is 12. So negative 4 and negative 8. Okay, I need to remember to plug in my originals again. So this was u minus 4. My original thing says u is a plus 2. So I have a plus 2 minus 4. And then I have a plus 2 minus 8. I can combine terms here. So this can be a minus 2, and this can be a minus 6. All I did was I combined my like terms. Okay, so again, a strange concept, but use that u to plug in when you've got something kind of funky, you don't really know what to do with it. See if the u will work. This last example is a pretty classic example. Let's just take a look. We're going to look at the middle term to find our u. So u is x squared. U squared is x to the 4th. Try this one. I think you can do it. Plug these back in for u's. When you get the u's, go back to the x's and go from there. There's one thing at the end which you might not catch, so I'll get to that one after you pause the video. Okay, when you go back and plug in your u's should look like this. Factoring, you can use the box method, you can use the AC method, you can use guess and check. I used guess and check, but I know not everyone likes guess and check, but since it was just a 2, I figured I could do it. So here's my guess and check. I need to plug back in my x squares, so I did that. And the last step that I was saying I wasn't sure if you'd catch was this x squared minus 4, because that's a difference of squares. We've been focusing on difference of cubes. Well, this is a difference of squares. And so that's x plus 2, x minus 2. So make sure you get those in there as well. The order of your factors does not matter. Remember, multiplication follows the commutative property. You can move things around. And so the order does not matter here for multiplication. All right, that is all. We had 2 factoring methods in this video. We had 2 factoring methods in the previous video. I think we are ready to do some factoring with polynomials. In the summary, write some things down. We learned a lot today, so write some things down in the summary that will help you remember when you go back and study for this test. You'll reread your summaries and do you remember what to do? So write some things down there, and then we'll practice in class.